All right, let's take a look at these, the idea of simultaneous equations. So the most common way of doing it is the elimination method. So you want to eliminate a variable. So anytime you have the same number of equations as you do pronumerals, theoretically you should be able to find the value of each of the pronumerals. Unless one of those equations is just a multiple of one of the others. So as long as you've got three, well, I was going to say three then, but however many distinct equations, and it matches the number of pronumerals. So you want to eliminate one, then you go and solve it for the other one. So this is assuming we started with 2, of course. And then you go and substitute back in and work out what the eliminator variable. That's the basic idea. So let's do a very simple one. 2x plus 3y equals 21, 5x plus 2y equals 3. We're going to eliminate one of those variables. And it doesn't really matter which one. Which one would you pick? Who'd go for the x? No one wants to eliminate the x. You like x. So does that mean everyone would eliminate the y? What did I do? I've multiplied the first one by 2 and the second one by 3. So yes, indeed, I also chose the y's to eliminate. So basically you want to make the coefficient the same so you can eliminate them. It doesn't matter about the sign, the plus or minus, because if the sign's the same, like I've got here, then all I've got to do is subtract. If the signs were different, then all I've got to do is add. So we're going to subtract 11x is negative 33, so x is negative 3. So we've solved for the other variable. Now substitute back in, and we get the eliminated variable. Write your final answer down. It's not for whoever's looking at your solution to pull everything together. So direct them to the final answer. So therefore x is negative 3, y is 9. Now I deliberately chose x and y here to illustrate something. This is not a coordinate geometry question, just because I've used x and y. So you don't write your answer as a set of coordinates, unless it happens to be a coordinate geometry problem where you're using simultaneous equations to find that. All right, here's one where that idea is not going to work. I can't eliminate one of the pronumerals because theoretically we've actually got 4 different pronumerals there, because x squared is different to x and y squared is different to y. So this one we're going to have to do by a substitution. You've got to make one of those pronumerals the subject. It's easier to make the ones to the power of 1 than the ones to the power of 2. I've again chosen y. So y is 14 minus 2x. Substitute it into the other one, and I guess in a way we have eliminated the y, or the y squared in this case. But we've got a quadratic to solve this time. Does 3 go into everything? And how do you know 3 does not go into everything there? Other than dividing by 3, of course. How do you tell if something's divisible by 3? Anyone remember the test? A number is divisible by 3 if the sum of its digits is divisible by 3. So 205 adds up to 7. 7's not divisible by 3. So 3 won't go into 205. And 56, same there, isn't it? 5 and 6 is 11. So all right, I can't go any further. Oh, geez, split the middle on that. Multiplies together to give 615. Adds together to give negative 56. Let's save some time. Oh, look, there we go. It's 3x minus 41, x minus 5 it ends up being. So we have 2 possibilities for x. All right, go back in and work out our corresponding values of y for each of those. So we end up with 2 possibilities. Now, how we write the final answer here is quite important. I don't just write x equals 5 or x equals 41 on 3 and y equals 4 or y equals minus 40 on 3 like I have there. Because that would imply there's actually 4 possible solutions. Because it's sort of implying I could match any of the x's with any of the y's. So more correct for this one to actually match up the only way it will work. And that is x equals 5, y equals 4. That's a possibility. And x equals 41 on 3, y equals negative 40 on 3. That's the other possibility. Let's say, as long as you've got the same number of equations as you do pronumerals, theoretically, we should be able to find them. So I've got x, y's, and z's. How do we do it? It's still the same idea. I'm going to now, from those 3, create 2 pairs of 2 equations. So basically I'm going to eliminate the same variable from all of the equations. So I'll start off, I'll multiply the first one by 2, which will give me 2x plus 4y minus 2z. This will allow me to eliminate the x's from the first two. And I get this new equation, 7y minus 6z equals minus 38. Now I pick another pair, and then I'll eliminate the same pronumeral. So I'll eliminate the x from it as well. So this time I'm going to multiply the top one by 4, and then I'll use the third one, because then the x's are the same on that one. Let's eliminate the x. 3y minus z equals minus 2. I now have two equations, two pronumerals, which I can solve the way we normally solve. And so this time I'm going to get rid of the z's, and we end up with y equals negative 2. Now I know what one of them is, I can work my way backwards and find all the others. So y is negative 2, z ends up being 4 when I substitute that into one of the equations. So I now know y and z, sub that into one of the original equations, and we can now work out x. So there's our final answer. X is 3, y is negative 2, and z is 4. 1G.